All right, hey there, Miss Weaver again, and this time we are looking at how to use StatCrunch when we want to graph or display quantitative data. And we're going to start with frequency distributions of discrete data. And in this case, I actually don't have great discrete data, days in office, but it's just very, the numbers, oops, the numbers are very big. So what I'm going to do is I'm going to pause for a minute and get us a piece of data that would be better suited for what I'm wanting to show you. So hold on just 1 second. Won't be any longer than that for you. Okay, so I now have a number of children, and this did have a couple of pretty high numbers. Apparently, John Tyler had 15 children. William Henry had 10. I did leave off any alleged children for a few of the numbers that were there. So, so let's start with looking at frequency distributions of discrete data. So if I need to create a table, then I can use stat tables. I want a frequency table. And so I'm going to find this data where I have number of children. And again, now in this case, cumulative frequency and relative frequency can be used. And then values ascending, so they'll start with 0 and go up to, in this case, I guess 15. And I think that's all we need to do. And so when we click compute, there is our table. Now, the one thing that is different is that normally we would not skip. So 7, 8, there would be a 9, and then there would be 11, 12, 13, 14, and they would all have zeros. So be careful of that. But otherwise, we can get our frequencies, relative frequencies, etc. And again, if you have a summary of discrete data, then the best option would be to go in and do that bar plot with summary. And just remember that for continuous data, we use a histogram. A histogram won't let us graph if we have a summary table, but we can remember that on a bar plot, that our bars should be touching if we have discrete data. So when we have that summary table, we can do that. And that will allow us also to get the relative frequencies just like we did with our qualitative data sets. So that's how we can get, let's see here. Oh, I've already marked these. I'm going to unmark them, I guess. So frequency distributions for discrete data, relative frequency distribution. So we just get to do all of those together. Cumulative frequency and relative cumulative frequency all happen in one fell swoop. Now, if I want to draw a histogram, if I have data, I can draw a histogram very simply. I'll go in. Let's say that I want to draw a histogram for the heights of our presidents. So I will go to graph, histogram. Let's see. Did I miss it? There we go, height in centimeters. And a frequency histogram is fine. You can change it to a relative frequency histogram if you want. Then as far as the bins, so this is the classes. If your homework problem has a lower class limit that it tells you about, or you have a table already set up where you can see what that lower class limit is, then you can put that here. Same with class width. If you know what the class width is, you can put that here. I don't actually know, so I'm just going to leave these and I might come back and change them. So this is going to just be a histogram from raw data for heights of our United States presidents. And so it actually did a pretty good job. Went from 160 to 165. notice, let me pull this up just a little bit. Notice that when I'm hovering over this bar, it has a bracket before the 160 and then a parenthesis after the 165. So what that means in interval notation is that we're including the 160 and we're going up to, but not including 165. So if we had had decimals, which of course we could with heights, it doesn't have to be exactly a set number of centimeters. It could be, we could have a decimal in that. Then I could say, you know, that I'm up to 164.9. So I'm going all the way up to 165, but not actually equaling 165. And then that's true for all of these. So 165, including 165 up to 170, but not including 170, and then so on. So this gives us, this actually has a class width of 5, which is very nice, nice, easy number. If I wanted to change that for some reason, then I could just change the width. I could say, no, you know what? I want a class width of 4. And then I have a more spread out. And then I see, oh, well, whoever this is, let's see, I think if I click on it, it'll tell me. So James Madison was 163 centimeters. And then the next tallest was at least 168. And so that shows the data just a little bit differently. I could also make it more than 5. So I could say, you know, I want 10 inches per bar. And of course, that's going to make me have less classes, less bars. And that's probably not as helpful. So it just depends on what you're trying to see with the data and what you're trying to discover. But in general, you're going to have all of these things are going to be determined for you by the question that you're working on. So that is a histogram from raw data. If we want to do a histogram from summary data, so again, let's say that I had, what would I have? Age at inauguration. I want to do a histogram for that, then, or let's say I want to do, I'm sorry, we just did histograms in general. So again, I'm going to uncheck that. If I want to get the frequency distributions and the relative frequency distributions when I have continuous data, then I think it's actually easier to just use the histogram. So I'll go in, make my histogram be my age at inauguration. I can make a frequency distribution. Again, I don't know, I might start at 40 and have a width of 5 years. And then I want to display the value above the bars because that's what I'm looking for. I'm looking for these frequencies. And so when I compute that, yes, I have a histogram, but I also have the frequencies. And not only that, a quick click will also get me the relative frequencies. And of course, if I need more than 2 decimal places, I can hover. So that, in my opinion, is much easier to identify and get those that we want. Now, one more thing, if I wanted to do a histogram and I wanted each number to have its own box, so like number of children, and I want to see the histogram for that. Well, I'm going to go in here and I'm going to change, there we go, number of children. Of course, we would start at 0 because I know that there was a 0 on my list. And I want a width of 1 because I want each number, this was discrete data, so I want each number to have its own bar. And then I'm going to go back to a frequency distribution. And now when I compute, I have each number gets its own bar on the histogram. And yet it still says from 0 up to 1, not including 1. Well, since this is discrete data, And that really just means 0. So we can make our histogram and it can still look great. But just remember that. That would be if we didn't, or I guess StatCrunch doesn't recognize whether or not we have discrete or continuous data. And so it just assumes continuous data. And that's okay. It can do that because whole numbers are going to work in this, whereas if they tried to just do whole numbers and we had decimals, we would have a problem. So all of that, and now see how we have this spread out for these empty classes. And it actually will tell us if we hover on the line, have a frequency of 0 for 12, frequency of 0 for 13, and a frequency of 0 for 14. All right, so I think, so that takes care of everything but dot plots and stem plots. So for a dot plot, to be honest, it's more about needing to be able to read a dot plot, but I'll show you how we can make one just in case you're asked to select a correct one. You can create one and compare. So to make a dot plot, this is probably one of the easiest ones to do. We just need to say, which of these do we want? And so I'm going to do age at inauguration. We just did that with a histogram, and so we will be able to see how closely these look. The difference being that, of course, this is going to make each individual number just have a column of dots above it, or maybe no dots, or just one dot, but it's just going to, each number is going to be its own column, which will be different than when we put it into classes. And let's see, so I don't think we need to change anything else here. I'm pretty sure that we can just compute and we get, yep, there we go. And we get a dot plot. And unfortunately, the numbers across here don't, even if you stretch it out as far as it will go, that axis does not get changed. And I don't think, oh, maybe we can. Tickmarks. What if we did 45, 50? I just so it tells us our min and our max. So if I want all the tick marks on 5s, hey, that's nice. Okay, so cool. And I guess we really could do every single number if we wanted to, but we really would need to stretch it out so that we'd have plenty of room for those numbers to show up. Because if we get it too scrunched, it starts to kind of blend together. So there's a dot plot. The nice thing about dot plots is we can see gaps, we can see clusters, kind of 2 clusters here, which is a little baby gap between them, a big gap here, and we can again see kind of this min and max, and of course we can hover and it'll tell us the exact number. So 42, 43. So that's a dot plot. And then last but not least, we want to look at how to make a stem plot. So stem plots, you'll both be reading and constructing. And so if we want to look at stem and leaf plot, of course, you're going to have your data. You cannot have a summary for stem and leaf plot. You're going to have the actual data. And maybe for this one, I guess, yeah, age at inauguration is just kind of the easiest one to do. Now, I will say this: if for some reason we had something that was that had decimals, so like the most common example I can think of is body temperatures, and so typically we go to 1 decimal place for body temperature, so 98.6, 97.4, 99.2, whatever that might be. And so we can identify that the leaf should be not a whole number, but that it should be the first, like just a 1/10 decimal place. And so if that's the case, we can change that here. StatCrunch should identify that naturally, but if you want to make sure, or if you think it's going to be different, you can change it. The other thing that we can do as well, so let's do this age inauguration first, and we can compute. And it does give us 2 rows for each number. So our 40s are broken down to 40 to 44, 45 to 49, 50 to 54, 50 to 59. So if your assignment is asking just for a regular stem plot where you only have 1 row for each tens place, then you would just place these numbers all in one line. But especially in a case like this where there would be so many on the 50 row, then it is actually kind of more helpful visually to see it broken down like this. One other thing that we might need to do, and I don't know if this shows up in the homework or if this would more just be a kind of a real life thing, if we were looking at days in office. So if I change this and I leave it with the leaf unit being 1, this is going to be extremely long, and this really isn't that great of a histogram or a stem plot, right? Like this is just lots of blank space, a few numbers here and there. There was a nice little line of numbers. Oh, I can't even get back to it now. There we go. So lots of people who had the same days in term. And so what I can do instead is if I made the leaf unit be the tens place, then that helps some. Right? So leaf unit is equal to 10. So the decimal place is to the 2 digits to the right of the colon. And so this would mean there was a whole lot of presidents who were around 1,460 days, 1,420, 1,430. So it definitely looks different, but sometimes, and this is one reason why a stem plot is not always the best plot. There's just such disparaging, like all these big empty spaces, that just a stem plot isn't always the best picture. If I have, though, one more just to show like stem plot may not be the best, if I look at number of children, oh, I left it at 10. I needed to, hold on, edit. I need to put that back to a 1. Compute. That's really not very telling either. So it's just basically puts everything in order, which I could do just by sorting. So stem plot, though, when we have something like age, height, those are things that we could do with a stem plot and it actually be meaningful. So I think that takes care, though, of all of the different qualitative, or excuse me, quantitative displays of data that we will look at. And if you have any questions, of course, reach out to me or your professor if I'm not that person, and ask your questions, and I will definitely try to help. And I'm sure your professor will do the same. So thank you, and hope you have a great day.